In this video, we're going to develop the basic paddle class. Now, a class of objects is like a factory that can produce objects. So our paddle class is only going to produce a single object because our game only needs one paddle. But it is conceivable that your game might, as you go from level to level, need to build new paddle objects that replace the old one, etc., etc. So to start a new class of objects, a new factory, we're just going to start a new tab and we'll name it capital P paddle. Um, in this class of paddle objects, you begin writing any class by typing the word class to tell the computer you want to make a factory, and then our factory is going to be called paddle. And our factory is going to do what's called implement game entity, which means our class promises that it will contain the methods that are in game entity. So our class will have an update method and a display method. So we can just write those right away and get rid of this red line. Void update, open brace, close brace, and void display. Open and close parentheses, open brace, close brace. Now, we have satisfied the requirements of the game entity interface. So again, this just groups objects with like behaviors together, an interface does. And so our game entity interface just has two void methods, one update and one display. And as long as any class that implements game entity has both a void update and a void display method, the interface requirements have been satisfied. So we are already in compliance, with the coughing. All right, to build a new class, you need to have a way for people to call the factory and actually build an object, and that's called a constructor method. And a constructor method has the same name as the class itself, and so when people call or make a phone call to the factory and ask to use the constructor method to build a new object, our factory will execute whatever code is in here, and I'll show you what that looks like in just a second. Our paddle object needs to know a few things about itself. It needs to know, it needs to have a float, which is like a decimal point container that contains its x position. We're going to say draw x. And then it has, I'm going to give it a target x, which is like the horizontal position that it's like sliding towards. It also needs to know how wide it is and how tall it is. So we'll give it those basic variables, those fields. These are called fields, which is like the long-term memory of an object. Now, we also need to know how high up off the floor of the window our paddle will kind of slide. So I'm going to say it'll slide like the height minus a fifth of the height. So if so it'll be a fifth. No matter how big our window is, it'll be a fifth of the way up from the bottom. And we're going to do this with a public final variable, an int. I'm going to call it y position, so y pos. And this will be the height of our window minus a fifth of the height of our window, which no matter how big our window is, we'll put it a fifth of the way up, which is just kind of a height that I think looks good. What is a public final variable? Well, it's just a way basically to give a name to a number, so that instead of our code just having like random numbers everywhere, now when we want to reference the paddle, like how far up from the bottom of the window it should be, we can just reference y pos, y position, so that it'll be clearer to people reading our code what we're meaning. With every single field, we need to, in the constructor method, provide a value to those fields. So at the beginning, our paddle is just going to be in the middle of the screen. So the width of our screen divided by 2. And the target to which the paddle is trying to slide will be the width divided by 2. Now this is a little bit fancy. This just kind of provides for smooth movement. We don't actually have to do it, but I'll show you because it's kind of fun. And then the width of our paddle, it can be whatever you want, frankly, but I'll start ours at 80 pixels wide And the paddle height, we'll just say this is 20 pixels wide. These two variables could just as easily have been a final variable, except that I know that it's possible that I will want to change these later based on like power-ups and stuff. So like maybe our paddle should be able to grow in width if it gets a power-up or something like that. So, okay. Now, in the update method, this is going to be kind of a weird one. Actually, let's do the display method first. So let's just have our paddle be kind of a dark gray. So fill just like 50, which is just sort of a dark gray. And then our paddle will just be a rectangle that is drawn at the draw X position, is drawn at the Y position, and is paddle width wide and paddle height tall. And this is just like a little extra thing. If you add an additional number here instead of just 4, you add 5. It's a rounding, like it'll have rounded corners, the rectangle, instead of just like exact corners. So I'll take this out for right now, but we might add that back in at the end of the video. Okay, for the update method now, we are going to have the position to which the paddle is trying to slide, the target X, equal to the mouse X, minus the paddle width divided by 2. So this just puts like the mouse in the middle. Oops, this has to be a capital. So this will just like, because the rectangle is drawn from the top left corner, this little line puts the paddle in the puts the mouse in the middle of the paddle instead. Okay, and so, but this next line is a little bit weird. So where the paddle is going to be drawn is going to be, it's going to slide towards the target. So, and we're going to do that in a kind of cool way. We're going to say the draw X equals the target X minus the current draw X times 0.1. So this is what's called tweening. Now, tweening means the paddle is being drawn here right now, but each time the paddle will slide, it'll add to its value plus equals, or here, this will be a better equals draw X plus, so its current value plus 1/10 of the distance between the target and its current position. So if it's far away from the target, it'll slide fairly quickly. If it's very close to the target, it'll start slowing down. It produces kind of a cool movement. You know what, and I'm going to add back in this rounding thing because it just looks nice. All right, so that's our full basic paddle class. Now let's go over and add one to our game. So the paddle for our game is just going to be, we're going to create a new paddle object above, outside of this void setup thing, way up at the top. This is where we're going to create things. So it's the paddle. And then in the setup method, we're going to build, like, we're going to initialize it, equals new paddle. And this chunk here is a reference to this method. And it sets all the initial values. Then we need to make the paddle update. So we say the paddle dot do your update method that we have written. And in the display function, we're going to draw a background. And let's just say our background is like almost white. And we want to, after we draw the background, display the paddle. All right, and so if we've done everything correctly and we run our code, we should see in the middle of the window a paddle object that will kind of track the mouse. But you see, if the mouse moves away, the paddle slides towards it. It doesn't just like awkwardly jump jittery towards it, and that is the tweening function. So our paddle looks pretty good at this point. That is it for the basic paddle.